Good evening, our listeners, and welcome to today's class. Today, we are still looking at probability-related question. However, today's own involves combinatorial analysis. That is combination and permutation in mathematics. Like this question we are given says, an excursion group of four is to be drawn from among five boys and six girls. That is, from amongst two groups containing five boys and six girls. A group of four persons will be selected to go for an excursion. The question goes further to say, find the probability of choosing the excursion group such that I, it is made up of equal number of boys and girls. That is to say, the four persons who will be selected to be in the excursion group will be made up of two boys and two girls. Whereas we have five boys in a group and we have six girls in a group. So what we are going to do here is to select two boys from these five boys and select six girls from these and select two girls from these six girls. So that in all we are going to have four persons who are going to be in excursion group. And of course, in mathematics, selection is combination. That is the number of ways of selecting a subgroup from a whole group. And of course, we know that the number of ways of selecting R objects out of N objects in mathematics is given as N combination R, where R is less than or equal to N. That is N combination R, or selecting R objects out of N objects. And it is expressed like this in mathematics, that N combination R equals what? N factorial all over R factorial into N minus R all factorial. And in this context, of course, we are going to select two boys from five boys and select two girls from six girls. That is, we are looking at, in this case, I am having what? Five boys, and I'm having what? Six girls. And I'm meant to select two boys from these five boys. So I'm selecting what? Two boys. And equally, I'm going to select two girls. So that these two boys plus these two girls will make up four persons who are going to be in excursion group. And I've always told us that selection in mathematics means a combination. So I am now going to say, in place of this N, I am going to use 5, and in place of this R, I am going to use 2. So I'll be able to have 5 combination what? 2 multiplied by. I will come over here, I'm going to select what? 2 girls out of 6 girls. And it's going to be 6 combination what? 2. And I'm going to express this 5 combination 2 the manner I expressed N combination what? R. And I'll be able to have that this will become 5 factorial in place of this N all over. Then in place of this R, I am going to have 2 factorial into 5 minus 2 factorial. The sign here is multiplied by. I will equally express 6 combination 2 the way I express this N combination R. And it becomes what? 6 factorial all over. We have what? 2 factorial into 6 minus 2 factorial. Of course, I can reduce this in this way so that I'll be able to have, now this is what? 5 multiplied by what? 4 multiplied by what? 3 factorial all over. What I have here is what? 2 factorial multiplied by 5 minus 2 is 3, and I have factorial outside. So I have 3 factorial. The essence of doing this is to enable me have 3 factorial up and equally have 3 factorial down so that they can cancel. So this will cancel this. I have here to do what? Multiply by. Here am I. Then I'll have 6 multiplied by 5 multiplied by 4 factorial all over. What I have here is what? 2 factorial multiplied by. Here is 6 minus 2 and 6 minus 2 is 4 and I have factorial outside. So I'll have 4 factorial. Same thing applies here because I have 4 factorial up and I have 4 factorial down and they will cancel. So this and this will cancel. And of course, 2 factorial means 2 times 1. And 2 times 1 is 2. And I have 6 here. So I can equally say 2 here is what? 1. And 2 here is what? 3. Then I come over here. This equally 2 factorial means 2 times what? 1. And 2 times 1, of course, is what? Is 2. So 2 here is what? 1. And 2 here is what? 2. So what I have here is what? 5 times 2. So I have 5 times what? 2 times. Here is what? 3 times. Here is what? 5. And 5 times 2 is what? 10. Times 2 is what? 30. And times 5 is what? 150. So I actually have this equals what? 150 ways of selecting 2 boys and 2 girls out of 5 boys and 6 girls to make up 4 persons who are going to be in excursion group. But of course, what we are required to do here is to find the probability of making this selection and not on finding the number of ways of making the selection. So for us to be able to answer that question, what we are going to do is we have been able to see the number of ways we can select 2 girls and 2 boys to make up the 4 persons needed in excursion group. So we are going to look at a way of making this selection without paying attention to whether we are going to have 2 boys or whether we are going to have 2 girls, but rather just selecting 4 persons out of 5 plus 6, which is 11, out of 11 persons who are going to go for the excursion without paying attention to whether the number of boys will be like this or the number of girls will be like that. We call such kind of a selection without restriction. Here, there was a restriction because we were told that we must have 2 girls and 2 boys. So selection without restriction here now is going to be, I'm going to have a selection without restriction. The first one was selection with restriction, where I was told how many boys and how many girls that is going to be here. Here is going to be without restriction. And without restriction is going to be 11 persons in all, which is this 5 plus what? 6. Combination what? 4. That is selecting 4 persons out of 11 persons. And of course, this is going to be expressed as 11 factorial all over. Here is going to be 4 factorial into 11 minus 4 factorial. And this is going to be 11 times what? 10 times what? 9 times what? 8 all over. Times 8 factorial all over. Here is what? 4 factorial into. Here becomes what? 11 minus 4 is going to give us what? 7. 11 minus 4 is going to give us what? 7. So I have a multiply by 7 factorial. Therefore, I need to move one step downward here, multiply by 7 factorial. Of course, this factorial, 7 factorial, can cancel this 7 factorial. And then what I'm going to have here now becomes that I'm going to have that this becomes what? 11 times what? 10 times what? 9 times what? 8 all over. For this 4 factorial, it is going to be expressed as what? 4 times 3 times what? 2 times 1. And here I have 4. 4 cancel itself is 1. Cancel 8 is what? Is 2. Here I have 2. 2 cancel this and cancel this is gone. Here I have what? 3. 3 cancel itself 1. Cancel 9 is what? 3. And I now have 11 times what? 10 times what? 3, which is equally going to be 330 ways. So I have 330 ways. So this is the number of ways of selecting 4 persons out of 11 persons without restriction. So we move further now to go and find the probability of doing this. I'll give you us 2 minutes to have a glance once again at what we have on the board before we can progress in looking at the probability. This is 5 boys, this is 6 girls. The question I says it must contain 2 boys and 2 girls. That is equal number of boys and girls. I picked 2 out of 5, picked 2 out of 6 by this, and at the end, I saw it to be 150 ways. Then here, I lumped these boys and girls together to have 11 persons, went straight to select 4 persons out of 11, and at the end, we arrived at 330 ways. So what we are going to do is to look for the probability. Permit me to clean this top here so we can look at the probability from that place. Okay. Now we are going to define probability in this context of this question, as probability is going to be defined as the number of ways of selection with restriction all over the number of ways of selection without restriction. Probability, let me write as what? P I. Probability, or let me just write as what? As P equals number of ways of selection with restriction all over number of ways of what? Selection without restriction. And of course, earlier on, we had got that the number of ways of selection with restriction is 150, and number of ways of selection without restriction is 330. Therefore, probability I or probability P equals what? 150 all over 330. And when we have something like this knot and this knot is gone. Of course, 3 can go into 15. When 3 goes into 15 here, it becomes what? 5. And when 3 goes into 33 here, it becomes 11. So the probability of making a selection of 4 persons that will be in the excursion such that it is going to involve same number of girls and boys is 5 over 11. So I want to believe that we did not confuse anybody in this question number I, as we looked at the probability of making a selection from 5 boys and 6 girls, 4 persons who are going to be in the excursion group, on the condition that it is going to contain equal number of boys and girls. Thank you very much for following us through in question number I. We are going to move down together in question number II. Question number II says, is either all boys or all girls? That is, we are going to select all of them to either be what? Boys, or we select all of them to either be girls. That is to say, to come to these 4 boys and go ahead and select 4 directly, who is going to go for the excursion, or we come to these 6 and directly go and select 4 who is going to go for the excursion. So in that case, the number of ways of selection is going to be, what is going to be now is, for question number II now, we are now going to say 5 boys is here and 6 girls is here. We are going to go directly and select 4 from these boys. Or we are going to come here and select 4 from these girls, and they will go for the excursion. That is all boys or all girls. And in that case, it's going to be 5 combination 4, or in mathematics means, in probability means what? Plus. So plus 6 combination what? 4. Then we go ahead and express the usual way we have been doing, and this thing becomes 5 factorial all over 4 factorial into 5 minus 4 all factorial plus. Here becomes 6 factorial all over Here becomes what? 4 factorial into 6 minus 4 factorial. And then this thing becomes 5 times what? 4 factorial all over. Here is 4 factorial. 5 minus what? 4 is 1. And I have factorial outside. Multiply by 1 factorial plus. Here becomes what? 6. Multiply by what? 5. Multiply by 4 factorial all over. Here is 4 factorial multiplied by 6 minus 4 is what? 2 factorial. I have 4 factorial here and I have 5 factorial here. This and this is gone. I have 4 factorial here and I have 5 factorial here. This and this is gone. I have 2 factorial here, which of course means 2, and I have 6 here. So 2 itself is 1, into 6 is what? Is 3. 1 factorial of course is 1. So what I have here is what? 5, and what I have here is what? 3, and what I have here is what? 5. Okay? So it is now going to be, here I have 5 plus 3 times what? 5 is what? 15. And of course, 5 plus 15 equals what? 20 ways. So there is 20 ways of selecting either 4 boys to go for the excursion or 4 girls to go for the excursion. And we recall that our probability here, because they still demand that we find the probability. That probability is number of ways of selection with restriction all over number of ways of selection without restriction. So we are still going to say that the probability is going to be 20 all over 330. So I still clean up here so that we can do it up here. So in this question number II, it is going to be number of ways of selection with restriction 20 here. So I have what? 20 all over number of ways of selection without restriction, which is the 330, which becomes what? 2 all over 33. Thank you very much. That question number II, which we want to believe that you followed us very well. Then we now come down to the last but not the least, which is question number II. But before then, let us have a little recap on what we have done in question number I. Here is 5 boys. We either selected 4 boys to be in the excursion group, or here is 6 girls. We selected 4 from the 6 girls to be in the excursion. And or means addition. So we have 5 combination 4 plus 6 combination 4. And at the end, we arrive at 5 combination 4 is 5, and 6 combination 6 is 15, and 5 plus 15 is 20. And then in the probability, number of ways of selection with restriction, all over number of ways of selection without restriction. Thank you very much, and permit me to clean the board. So we go over to question number II. That II says 3 boys and 1 girl. Of course, in total, that is question number III. We have 5 boys here. We have 6 girls here. We are meant now to select what? 3 boys to be in the excursion. Select 1 girl to make it 4 now to be in that excursion. So I'm selecting 3 here and I'm selecting 1 here. And by so doing, what I'm going to have here becomes what? 5 combination 3 and means what? Multiply by. Here is what? 6 combination what? 1. Then expressing them as usual, I'll be able to have that this is equals 5 factorial all over. We have what? 3 factorial into 5 minus what? 3 factorial multiplied by 6 factorial all over 1 factorial into 6 minus 1 factorial. And then this thing is now going to be 5 times what? 4 times 3 factorial all over. Here it becomes what? 3 factorial. 5 minus 2 multiplied by 2 factorial. So what we have here now, this factorial will cancel this factorial. This 2 factorial 1 into 4 is what? 2. Here is multiplication sign, multiplied by. Here we have what? 5, we have 6 multiplied by 5 factorial all over. Here is 1 factorial multiplied by 6 minus 1 is what? 5 factorial. So here there is 5 factorial, here there is 5 factorial. This and this will cancel. And of course, 1 factorial is 1. Then I'm left with what? 6. And in that case, what I have is 5 times 2, which is what? 10. 10 times 6, which is 60. So we have 60 ways of doing this thing. 60 ways of doing this selection II. But then we are required to find its probability. So looking at its probability, we still return back to our definition here. Number of ways of selection with restriction, all over number of ways of selection without restriction. And in that case, permit me to clean this probability I have for II. And it is now going to be number of ways of selection with replacement with restriction is 60. So I have 60. Number of ways of selection without restriction is 330. This equals, of course, 0 and 0 here is gone. I have 6 all over 33. Of course, 3 can go into this. When 3 goes into this is what? 2 all over. When 3 goes into this is what? Is 11. So we have 2 over 11 as the probability of having 3 boys and 2 girls in the group. We thank you for your audience, and we plead and encourage with you as usual that situation whereby you find the class interesting and valuable, that you help us subscribe in our YouTube channel, comment and share with their friends and their families. Thank you very much for listening. And let us equally look at one other number that concerns this probability involving combination and permutation. But then